Alright, this video is for the calculator portion of your Unit 10 test review for Honors Algebra 2. The first part of the calculator portion is just reviewing of simplifying and rationalizing square roots. Alright, so we start with the square root of 32. And just to simplify this, you want to make sure that you know what perfect square goes into 32. The biggest perfect square would be 16. So you can rewrite this as the square root of 16 times the square root of 2. And that's because 16 times 2 is 32. And then you simplify the 16 to be 4 radical 2. And this would be your most simplified answer. All right, in B, you have a coefficient of 5. The coefficient of 5 just sits out in front. When I have a negative under the square root, remember that is going to be I. So we pull out a square root of negative 1. And then the square root of 49 is a perfect square. So when we simplify this, we have 5, square root of negative 1 is I, times the square root of 49 is 7. Well, we can multiply those quantities together and get 35I as the solution. All right, in C, we have a negative out in front of the radical, but that negative is our coefficient, like a negative 1. So you're just going to leave a negative in front. It's not going to become an I. The square root of 24, the biggest perfect square that goes into that is 4, and 24 is 4 times 6. When you simplify this, the square root of 4 just becomes 2. Our negative coefficient stays put, and the square root of 6 stays the same. So that is going to be your fully simplified answer. All right, in D, when you have a fraction under a radical, remember that the radical will break up over top of the fraction. So we can rewrite this as square root 11 over the square root of 4. And then you simplify both radicals. The square root of 11 does not simplify, but the square root of 4 does simplify to 2. Because I do not have a square root in the denominator, I am finished, and that's my final answer. Now the next problem looks very similar, but it is radical 4 over radical 11. So again, let's start by breaking up the radical over the numerator and the denominator. That simplifies to be 2 over radical 11. However, in this problem, because the square root is in the denominator, I need to rationalize the fraction. To rationalize this fraction, I multiply by a fancy 1, which is the square root of 11 over the square root of 11. You take the denominator and turn it into a 1. Now you multiply straight across the fraction. 2 times radical 11 is 2 radical 11. And radical 11 times radical 11 is radical 121, which is 11. Nothing else simplifies here. So 2 radical 11 over 11 is the rationalized and simplified form. All right, 1 over radical 7. Again, I have a radical in the denominator. Radical 7 does not simplify. So I'm going to go ahead and, oops, wrong number. Go ahead and multiply by radical 7 over radical 7. I multiply straight across, and the numerator becomes 1 radical 7 over 7, right? Radical 7 times radical 7 is radical 49. The square root of 49 is 7. This does not simplify anymore, so that is your final answer. In G, radical 15 does not simplify, but because it's in the denominator, I need to rationalize. I will multiply by radical 15 over radical 15. When I multiply across the numerator, I get 3 radical 15, and my denominator, again, simplifies to the radicand, 15. Now in this problem, the coefficients, 3 and 15, can simplify to 1 over 5. So this becomes radical 15 over 5. That is your fully simplified form. All right, now this last one, 2 radical 8 over 6. There's a little bit of work here. First of all, I want to simplify the square root of 8. Right, the square root of 8 is radical 4 times radical 2, which simplifies to 2 radical 2. So I'm going to rewrite that as our coefficient of 2. I'm going to bring down that 2 radical 2 to replace the radical 8. And that is all over radical 6, and radical 6 does not simplify. Now let's take a minute here and simplify the numerator. 2 times 2 radical 2 is 4 radical 2 over radical 6. And what I'm going to do now is I need to rationalize the denominator. I cannot leave that radical 6 in the denominator. So I'm going to multiply by radical 6 over radical 6. When I multiply across the numerator, that becomes 4 radical 12 over 6. Which is a good thing here. But I can't leave the radical 12 because radical 12 simplifies, and also the 4 and the 6 will simplify. So let's actually start with simplifying the radical 12, and then we can simplify the coefficients. Okay? So radical 12 here, I'll rewrite this, we'll do it the long way. We have 4 times, well, radical 12 is simplified to 2 radical 3 over 6. That becomes 4 times 2, is 8 radical 3 over 6. And then we can simplify the 8 over 6. Well, I'll ask my pen here, it'll pause. But 8 over 6 there was simplified to be 4 over 3, and I bring that radical 3 back to my numerator. So the fully simplified form here is 4 radical 3 over 3. That one was a little bit more involved. Hopefully, through your practice and these problems, you understand rationalizing fractions well. All right, now, we have some more rationalizing to do, but in order to do that, we need to review what a conjugate is. Remember, the conjugate has the same terms as a complex expression, but an opposite sign. So if I have I minus 6, its conjugate is I plus 6. For 8 minus radical 3, its conjugate is 8 plus radical 3. And the same thing in C and D. Our conjugate here would be 2x minus 9. And in D, the conjugate would be 13 minus radical 2. Now, we are going to use conjugates later this year. You'll use it again in pre-calc and calculus. But for our purposes at the moment, we use conjugates to help simplify more complicated looking fractions that have radicals. So for example, in A here, we have 2 over 8 minus radical 3. To simplify this, I multiply by the conjugate, all right? I don't rationalize it the same way I did in number 1. So the conjugate here is 8 plus radical 3. And you're going to multiply the numerator and the denominator, and then simplify so that you get your final answer. So remember, in the numerator here, you need to take the 2 and multiply it by both the 8 and the radical 3. So that will become, 2 times 8 is 16, plus 2 radical 3. Now I'm going to write the denominator out the long way. You need to, I suggest putting the denominators in parentheses so that you can double distribute here. 8 times 8 is 64, plus 8 radical 3, minus 8 radical 3, and then negative radical 3 times radical 3 simplifies to be minus, because it's a positive times a negative, 3. Now, every time you do these problems, the middle terms here are going to cancel away, which is good because that takes the radical out of the denominator. The numerator stays at 16 plus 2 radical 3, and then our denominator is 64 minus 3, which is 61. That does not simplify, so that is your most simplified answer. All right, in B, similar problem. I multiply by the conjugate as a fancy 1. So I have 7 plus radical 5 over 7 plus radical 5. I multiply the numerators together, so I multiply the 1 by both terms in the other numerator, which ends up just being 7 plus radical 5. In our denominator, I again have to distribute. 7 times 7 is 49, plus 7 radical 5, minus 7 radical 5, and then we're going to have a minus again because it's a negative times a positive, and radical 5 times radical 5 is 5. Those inside terms cancel off, so your final answer, the numerator stays the same, and you have 49 minus 5, which is 44. And that would be your fully rationalized expression. All right, let's move down to C and D, a little bit more complicated, a little bit more involved. 1 over 3 plus radical 2. The conjugate in C is going to be 3 minus 2 radical 5 over 3 minus 2 radical 5. All right, same thing. We multiply our numerator together, so the 1 gets distributed to both parts, which is nice. It doesn't change the value. We have 3 minus 2 radical 5. And our denominator, we need to distribute. Right, so multiply. We have 3 times 3, which is 9, minus 6 radical 5, plus 6 radical 5. Now, be careful here. 2 times negative 2 is negative 4. Radical 5 times radical 5 is 5. So actually we need to write that as minus 4 times 5, which we notice the middle terms cross out. That 4 minus 5, or I'm sorry, negative 4 times 5 here is negative 20. So really our simplified form is 3 minus 2 radical 5 is our numerator, and then over 9 minus 20, which is negative 11. That would be your simplified form. So here you have to make sure that when we multiply to the 2's and the radical 5's together. All right, last one in D. Before we start, we should notice that we have a radical 9 in the numerator. And radical 9 simplifies to be 3 over 2 plus radical 11. So you just have to do a little bit of simplifying there to start. Now we can multiply by the conjugate as a fancy 1. So 2 minus radical 11 over 2 minus radical 11. All right, when we multiply our numerators, the 3 goes to the 2 and the negative radical 11. To simplify to be 3 times 2 is 6, minus 3 radical 11, all over, and we multiply our denominators. 2 times 2 is 4, minus 2 radical 11, plus 2 radical 11. And again, a positive times a negative is a negative 11. The inner terms cross off. Our numerator is 6 minus 3 radical 11, and the denominator is 4 minus 11, which is negative 7. That would be simplified. All right, if you need more help with rationalizing fractions, we have lots of practice, or ask your teacher. That's really easy to write and come up with some questions for you for extra help. All right, let's talk about solving square root equations here. Okay, so we'll do number 4 will be the last problem on this video, then we'll have a different video for the no calculator section. All right, so we have to solve each of the following square root equations. Make sure we're checking our answer every time so we can see if an equation or an answer is extraneous or not. In A, we double check. Remember, we double check that there's nothing going on outside of that radical bubble. And there isn't in this problem, so we are able to start by squaring both sides. We need to get rid of the square root. When I square the left-hand side, the square cancels. It's the inverse of the square root. So I have 3x minus 5 equals 49. From here, it's really easy just to solve this problem by adding 5, 3x equals 54, and dividing by 3. And we get that x equals 18. Now we need to check our answer here, because remember, we can't just go by the fact that we got x equals 18. We must check by typing this value into our calculator. And there's a couple ways to do that. We can use the table feature on our calculator, the graph feature, or we can just type in the expression with 18 for x, which is what I'm going to do here. So I'm going to type in our square root. Oops, that's not what I wanted. I want to be in main screen. Square root. We'll have 3. Now instead of x, you type in the 18 that we found, minus 5. When I hit enter, I get 7. And notice that here, I had 7 as the solution, which is what we wanted. So that means that x equals 18 is your solution, and there were no extraneous answers in this problem. Okay, 18 was your solution. All right, in B, this didn't go well on my computer. There's a radical. When we start this problem, we need to remember that we have this radical bubble in a way right here, right around the square root of x over 3. So I cannot touch that radical until I deal with the 1 and the 2. So I have to subtract 1 first. That's the first step. And then I'll have 2 times radical x over 3 equals 8. I still am not allowed to touch the radical. I still need to deal with the 2 that's out in front. So I divide both sides, and I'll have the square root of x over 3 equals 4. Well, from here, I can go ahead and square both sides. Now I'm allowed to get rid of that square root. So x over 3 equals 16. And then I can multiply both sides by 3. And I get that x equals 48. Now again, I cannot just take 48 as my answer. I have to check it back in the original equation. So I'm going to do the same thing again. I'm going to go to my calculator and start typing the expression. 2 times the square root of, I'm going to make a fraction here, 48 over 3. Now outside the radical, I put a plus 1. And when I hit enter, I get 9. Again, 9 is the number from the original solution. That's what we wanted when we put x in for 48 in for x. So I know that x equals 48 is a solution. That was the only one, so there were no extraneous solutions. All right, let's make it more challenging. Let's try part C. All right, on the left-hand side, there's nothing going on outside the radical, which means I'm free to move and get rid of that square root. So to start this problem, I'm going to square both sides. But when I square the right-hand side, I need to remember that I'm squaring the entire quantity x minus 2. So on my left-hand side, the square root does go away, but the right-hand side needs to be rewritten as x minus 2 times x minus 2. You need to double distribute on this problem so that you're actually fully multiplying. Now the left-hand side stays 3x plus 4. The right-hand side, when it simplifies, I'm going to do the final simplified answer here. You can take it out an extra step if you need. Is x squared minus 4x plus 4. Now what we want to do is because I have a squared, my goal is to get everything on the right-hand side, so I have a 0 equals, and I can solve by factoring. So I'm going to move the 3x, and I'll move the 4 at the same time by subtracting it from both sides. When I do that, I get 0 on the left equals x squared minus 7x, and notice those 4's cancel off. Well, now I can solve, I'm going to continue by factoring here. I have a GCF I can pull off. So I have 0 equals x times x minus 7. Now in order to actually get the solutions, I use the zero product law, which sets each factor equal to 0 and solves. So I have the possibility of x equals 0 and x equals 7. I cannot count those as solutions until I check them in my calculator. So I'm actually going to show you a different strategy here. I'm going to use the table feature on my calculator to check this answer, but you can just type things in like you did before. In order to use the table, I would graph, or I'm going to type in the equation, the square root of 3x plus 4 in one of my y equals. Then I put the other side of the equals, the x minus 2, as a different equation in my calculator. Now to use the table to check this, I go to the table. Now I look at x equals 0 right at the top here. Because y1 and y2, the outputs are different for either equation, that means that 0 is not a solution. So when I go back to my paper here, 0, I cross it off. X equals 0 is extraneous for this problem. When I look at x equals 7, lower on my table here, you can see, it won't let me circle it, but they have y equals 5 for both of the equations. That means that 7 is a solution for both equations for y equals 5, and that means 7 is a solution. Now, if you needed to visually see what that means, hit your graph. you should see that our graphs intersect, and it looks like they intersect at x equals 7, but only one place. At x equals 0, our graphs do not intersect. That's why 0 is not a solution. All right, one more problem here. All right, I have a big square root over 2x squared minus 5x minus 12 equals 0. I'm going to start by squaring both sides just to get rid of my square root. So what I have is 2x squared minus 5x minus 12 equals 0. All right, now, in order to solve this, I need to factor, and I'm going to factor by split the middle. So I need to find two numbers that multiply to negative 24 and add to negative 5. That's going to be negative 8 and 3. So when I do split the middle here, I'm going to have 2x squared minus 8x plus 3x minus 12. I group. I'm going to go pretty quick through the factoring here because you should be able to factor by split the middle at this point in the school year. And the GCF for the second group is 3. Notice that the factors are the same, which is a good thing, so that you can write your factored form as 2x plus 3 times x minus 4. To find your solutions, you set each of those factors equal to 0, which gives you on the left one, x equals negative 3 over 2, and x equals positive 4. Now, we want to check both equations here. So there's a couple ways to do this. Because we're set equal to a number, it would be very easy to take each of these x's, type them into the calculator, just the plain screen here. So you could go, I'll show you the first one. You could do square root of 2 times, let's check 4, because 4 is an easier number. 4 squared minus 5 times 4 minus 12. And enter, I get 0, so I know that 4 is a solution. All right, so 4 is good. We know x equals 4 is a solution. We can also use our table like we just did in the last problem, or I'm going to show you how to use the intersection on your calculator. All right, so you could check negative 3 over 2 the same way, but I'm going to show you using your calculator. So we type the left side of the equals into our calculator. The square root of 2x squared minus 5x minus 12. And then the other y equals is y equals 0. That was the other side of our expression. All right, now it's hard to tell from your graph because of the way your graph does this problem. But what we're going to do is we can trace the intersection here. So we'll go down to option 5. And let's see. Right. Let's bring our cursor so we can see it. There we go. So we'll hit, once we see it, we can hit enter 3 times. Oh, and it does tell us, we had some, hold on. Did I type that in right? I did. I think it's just the way the graph is. So maybe we won't use the graph for this one. Although you could if you wanted to. I don't want to waste our time trying. So let's check negative 3 over 2 here. So I'll have square root of 2. I'm going to use negative 1.5 instead of 3 over 2 just so I don't have to type the fraction. Minus 5 times negative 1.5 minus 12. And when I hit enter, I get 0, which is the output I want. So on this problem, I have 2 answers, 4 and negative 1.5, so there are no extraneous solutions. All right, if you need extra help on that section, your teachers do have an extra practice for you if you'd like it. If you need help on the calculator part, there'll be a different video.